Good morning. In the previous session, we have started for the advanced technical trainings on the hydraulic engineering, and we have started for the topic dimensional analysis and the hydraulic similitude. That is from the point of view of the GATE and the end semester exam. Sorry, ESC, that is Indian Engineering Services examination. Okay. So in the previous class, the part which we have discussed, that was about the meaning of the dimension, meaning of the unit. After that, we have discussed about the Buckingham Pi theorem, that is methods of dimension analysis. And after that, we have discussed the examples and the multiple choice questions. Those were asked in the GATE examination and the ESE. Okay, along with the solution, this part we have discussed already. Now in the today's session, we'll start for the next part. That is a model, prototype, then similarities, similitude, etc., etc. Okay, in the previous class, along with the Buckingham Pi theorem and its significance, we discussed about the dimensional numbers and their significance also. It is a Proud number, then Reynolds number we have discussed about, then Euler number we have discussed about, Mach number we have discussed about, Weber's number we have discussed about, their significance. Okay, and after that we have discussed those examples also. Those were asked in various GATE examinations. Now, today we'll go for the types of the, firstly, before proceeding to the types of the similarity, I would like to go for the highlighting the things related to the model and prototype. What does it mean about the model and what does it mean about the prototype? Firstly, what is the model and what is the prototype? So model is nothing but a replica. A model is an actual machine, whereas the prototype is nothing but the replica of that model. As an example, I would like to go for whenever we want to go for any plan of the building, that may be the 2D or a 3D in AutoCAD. So as an example, I'm considering in an AutoCAD, whatever the sketch we are preparing, that is nothing but the model of a actual machine, of a actual structure which will be get constructed in a reality on the ground. It means the whatever the building which you are going to construct on a ground, it's a replica we are making in a AutoCAD software. That is nothing but the model of that. Similarly, whenever we want to go for a construction of any big hydraulic structures, for example, that may be the weir, that may be the dam, hydropower stations, etc., etc., or the bridge. And in that case, it's required to go for analysis of the structure under the various forces. Means we have to analyze the behavior of the structure under the application of the various forces. Because if it happens that there is an submergence or the overflow of the dam, it is to happen so rarely, but in case of the weirs, it is to be an frequently. During a monsoon season, each and every weir undergoes the submergence. यानी कि जब भी बारिश शुरू होती है तो बारिश के मौसम में क्या होता है, जो भी वियर्स होते हैं उसको मराठी में बंधारा बोलते हैं, वो सब पानी के नीचे जाते हैं. तो उसके टाइम क्या हो जाता है, सो अंडर सच कंडीशंस, if you are considering the forces acting on that particular structure, yes, that structure is going to withstand against those forces. That analysis is required to go for before the construction of the structure. Now thing is that why to go for the before the construction of the structure, यानी कि वो स्ट्रक्चर तैयार करने से पहले ही उसके ऊपर जो फोर्सेस आ रही है उसका स्टडी क्यों करने का है. मान लो कि आप एक बांध बांधने जा रहे हैं, डैम कंस्ट्रक्ट करने जा रही है, और आपने उसका पहले कुछ स्टडी बिना करके डायरेक्टली आपने आर्बिट्रली वहां पे कंस्ट्रक्ट कर दिया. By for construction of the dam, we need to require investing a huge amount of the money over there. उसके लिए जो लगने वाला जो मैन पावर है, जो लगने वाला मनी है, जो पैसा लगने वाला है, वो बहुत सारा लगता है. और उसके बाद में यदि आपको ऐसा पता चल गया कि जहां पे आपने डैम कंस्ट्रक्ट कर दिया है वहां पे जो फ्लड आता है उसका मैग्नीट्यूड आपने जो डैम कंस्ट्रक्ट कर दिया है उससे ज्यादा है, तो उसमें क्या हो जाएगा, डैम विल बी गेट सबमर्ज्ड एंड इट विल बी नॉट यूटिलाइज्ड फॉर द पर्पस ऑफ द फ्लड रेगुलेशन. अगेन दूसरा क्या हो जाएगा, बहुत बड़ा बांध लिया आपने, लेकिन क्या हो गया है, जो फोर्सेस आ रहे हैं, यानी कि जब फ्लड आएगा तो उसके ऊपर बहुत सारा पानी का जो हाइड्रोस्टैटिक फोर्स लगेगा वो ज्यादा लगेगा. उसके बीच में मान लो कि अर्थक्वेक भी हो गया तो उसमें क्या होगा, हाइड्रोडायनामिक फोर्सेस आ जाएंगे. तो दोनों का कॉम्बिनेशन होकर क्या होगा, स्ट्रक्चर पूरा आपका कोलैप्स हो जाएगा. तो इतना बड़ा स्ट्रक्चर यदि कोलैप्स हो जाएगा तो बहुत सारा जो वहां पे हमने जो पैसा इन्वेस्ट किया है, दैट मनी विल बी गेट वेस्टेड. Along with that, it will result in the submergence of the area lying nearby that dam. यानी कि जो भी उसके निचले भाग में जो भी आने वाला ये रीजन है वो फ्लड की वजह से पूरा के पूरा पानी के नीचे जाएगा, यानी कि क्या हो रहा है यहाँ पे, डैमेज हो रहा है. So to avoid those things, we need to go for firstly a construction of the model, and we have to study the model firstly. We have to analyze its performance. We have to check its performance under various conditions of the forces and all those things. And after that, we have to go for the actual machine or actual prototype, we can say. Same thing we used to do in AutoCAD also, or in the softwares like the ANSYS, etc. Those are used for the analysis of the structures. And कि जो भी different forces हैं, वो forces लगाने के बाद वो structure का behavior कैसा रहता है, वो हम study करते हैं. और उसके हिसाब से क्या करते हैं हम, उसमें जो लगने वाला स्टील है, वो जो भी लगने वाला फाउंडेशन है, उसका टाइप हम चेंज करते हैं, उसके लगने वाली क्वांटिटी हम चेंज करते हैं, ताकि जो स्ट्रक्चर है हमारा, वो स्ट्रक्चर जो भी लोड आएगा उसको वो बियर करेगा. वो हम बहुत बार क्या करते हैं, मैन्युअली भी कर देते हैं और वो सॉफ्टवेयर में भी कर देते हैं. यानी कि हमने क्या किया, फर्स्टली वी स्टडीड इट्स मॉडल, एंड आफ्टर दैट वी आर गोइंग टू कंस्ट्रक्ट इट्स एक्चुअल स्ट्रक्चर, दैट इज अ प्रोटोटाइप. बट बहुत बार ऐसा लगता है हमें कि मॉडल हमेशा प्रोटोटाइप से छोटा होना चाहिए. ऐसा नहीं है, हमेशा मॉडल प्रोटोटाइप से छोटा नहीं होता है. फॉर एग्जांपल, इफ यू वांट टू कंस्ट्रक्ट अ मॉडल ऑफ अ रिस्ट वॉच, जो हमारी घड़ी रहती है, उसका यदि हमें मॉडल बनाना है, नहीं तो हमें मान लो कि एक छोटी सी चिप है मोबाइल में से रहती है, नहीं तो आईसीज रहते हैं बहुत सारे मोबाइल में, लैपटॉप्स में, बहुत सारी इलेक्ट्रॉनिक डिवाइसेस में. उनका जब हम मॉडल बनाते हैं तो उनका मॉडल वो प्रोटोटाइप से बड़ा रहता है, यानी कि जो भी एक्चुअल मशीन रहता है उससे उसका डायमेंशन ज्यादा रहता है. It means that the models are not always the same, smaller in dimension that of the prototype. It may happen that they are in a larger dimension or having a big dimensions than that of the prototype. और उसके ऊपर एक बार गेट में एक क्वेश्चन पूछा था, the models are always having a smaller in dimension that of the prototype. It's not true. Okay, sometimes we need to go for the models of a larger dimension or bigger size than that of the prototype. This is about the initial idea of the what is meant by a model and what is meant by the prototype. Okay, उसके बाद में जो आता है दो, that means the similitude के पहले मैं जाना चाहता हूँ types of similarity. या अभी हमने देखा कि मॉडल देखा, प्रोटोटाइप देखा, उसका मीनिंग हमने अंडरस्टूड कर दिया. उसके बाद में क्या रहता है, जब हम मॉडल प्रिपेयर करते हैं, जब भी हम मॉडल प्रिपेयर करते हैं, तब प्रिपेयर करते वक्त हमें बहुत सारी चीजें ध्यान में रखनी पड़ती है. उसके ऊपर आने वाली फोर्सेस रहती है, ओके, उसके डायमेंशंस रहते हैं, उसकी बहुत सारे जो फ्लो पैरामीटर्स रहते हैं, वो पैरामीटर्स हमें देखने पड़ते हैं. सो बाय कंसीडरिंग टू दैट, यानी कि जब भी हम एकदम मान लो कि एक मॉडल बना रहे हैं, तब वो बनाते वक्त उसको प्रोटोटाइप के सिमिलर स्केल में हमें बनाना पड़ता है. सिमिलर स्केल इन द सेंस व्हाट, दैट सिमिलरिटी इन टर्म्स ऑफ द geometry, kinematic and dynamic. So 3 similarities we used to go for mainly. That is a geometric first one, second one is a kinematic, and third one is the dynamic. We'll discuss now that those similarities between the model and prototype in details firstly, and then we'll go for the related questions those were asked in the GATE and ESE. So firstly, I would like to go for the first type of the similarity that used to be there in between the model and prototype. It is a geometric. So geometric similarity means what? So when to say the model and prototype are geometrically similar. So geometry in the sense, now we are getting the idea. So geometry is nothing but the length, height, width, etc., etc. Those are the parameters related to the geometry or a shape, we can say. So whenever we are saying that there is a geometric similarity between the model and prototype, it means that whatever the different scale ratios those used to be there, means length of model and length of prototype, then area of the model, area of the prototype, volume of the model, volume of the prototype, ये जो ratios आते हैं, वो ratios क्या रहते हैं, सेम रहते हैं. लेंथ का रहेगा, विड्थ का रहेगा, एरिया का रहेगा, वेलोसिटी का रहेगा. यदि वो जो डायमेंशनल के हिसाब से, यानी कि जो भी हम लीनियर डायमेंशन ले रहे हैं यहाँ पे, लेंथ, विड्थ, एक्सेट्रा एक्सेट्रा, एंड अलाइड डायमेंशंस टू दैट, इट इज अ वॉल्यूम, एरिया. यदि वो डायमेंशंस का जो स्केल रेशो आएगा, मान लो कि हम लेंथ का स्केल रेशो ले रहे हैं, यानी कि उसको हम एलआर बोलते हैं, लेंथ स्केल रेशो को हम एलआर बोलते हैं, कि क्या रहता है, length of model divided by length of proto, or length of proto divided by length of model. One and the same we will get. So this ratio, if it is having a same, it is adapted same for the preparation of the model from the prototype, then in that case we used to say that there exists a linear geometric similarity for the length. उसके साथ और कौन कौन से आते हैं, उसके साथ विड्थ है, डेप्थ यानी हाइट रहता है, बाद में एरिया आता है और वॉल्यूम आता है. इट मींस दैट वी कैन से दैट देयर एग्जिस्ट अ geometric similarity between the model and prototype if the ratios of corresponding length dimension in the model and prototype are equal. And such ratios are called as scale ratios, and they are written like as a length scale ratio as a LR. Similarly, if you want to go for the width scale ratio, then I will to go for a width as a B, that is for the model divided by a proto, and depth or the height, depth I would like to go for depth of the model divided by depth of the prototype, or instead of the depth I would have to go for a height of a model divided by height of a prototype, etc. This is about the length scale ratio. Then next scale ratio जो आता है, that is the area scale ratio. Means under the geometric similarity, next scale ratio is the area scale ratio. Means area of the model divided by area of the proto. ये जो ratio आएगा, if this is the same one, then in that case we used to say that there is a geometric similarity for the area scale ratio. So area यानी कि क्या रहेगा, मान लो कि आपके पास एक स्क्वायर प्लॉट है और तो रेक्टेंगल है, तो क्या आएगा, लेंथ इनटू विड्थ आएगा उसका एरिया. सो आई हैव टू गो फॉर अ लेंथ ऑफ अ मॉडल इनटू द विड्थ ऑफ अ मॉडल डिवाइडेड बाय लेंथ ऑफ प्रोटोटाइप इनटू द विड्थ ऑफ अ प्रोटोटाइप. Isn't it? यानी कि क्या हो गया, at the last width also is nothing but the length parameter. क्योंकि सेकंड पैरामीटर विड्थ को हम लेंथ कंसीडर कर देते हैं तो लेंथ हो जाएगा, यानी कि लेंथ ऑफ मॉडल इनटू द लेंथ ऑफ मॉडल ऐसा हम कंसीडर करेंगे. यानी कि इट इज इन द टर्म्स ऑफ द डायमेंशन, इफ यू आर टॉकिंग अबाउट एज एन विड्थ, then width is nothing but a length dimension. So it will be nothing but the length of a model square divided by a length of a proto square. क्यों आएगा, जब ये हमारा एग्जैक्टली स्क्वायर ब्लॉक रहेगा तो लेंथ और विड्थ उसका सेम पकड़ रहे हैं. दैट इज नथिंग बट द LR स्क्वायर. वी कैन राइट लेंथ स्केल रेशियो आएगा LM by LP, यानी कि क्या है, LR है, लेंथ स्केल रेशियो है, इसका स्क्वायर है, LM का स्क्वायर है, LP का स्क्वायर है, तो ये क्या आ जाएगा, लेंथ स्केल रेशियो का स्क्वायर आ जाएगा. सिमिलरली फॉर द वॉल्यूम स्केल रेशियो, VR आई वुड लाइक टू गो फॉर. वॉल्यूम स्केल रेशियो क्या रहेगा फिर, वॉल्यूम ऑफ द मॉडल divided by a volume of the prototype. और वॉल्यूम में क्या आ जाएगा, लेंथ विड्थ इनटू हाइट आ जाएगा. सो लेंथ ऑफ अ मॉडल, विड्थ ऑफ मॉडल इनटू द हाइट और द डेप्थ ऑफ द मॉडल डिवाइडेड बाय लेंथ ऑफ द प्रोटो, विड्थ ऑफ द प्रोटो इनटू द हाइट ऑफ द प्रोटो. एंड वंस अगेन that will be a width and the height is nothing but the, once again we are considering as a dimension as a length. So it will be now a L cube of a model divided by a L cube of a proto, that is equals to LR cube. We can write it is a cube of a length scale ratio. Here LR is LM by LP. LM by LP is there, but there is a cube, so I would like to write here as a LR cube. Okay, it means that if there exists a geometric similarity between the model and a prototype, then it is in that case we can say that the scale ratios of the length, area and the volume are the same for the that model and prototype. This is about the geometric similarity. The next similarity, that is the second one I would like to go for, that is a kinematic similarity. Kinematic similarity between the model and prototype. Now when to say there is exist a kinematic similarity? So firstly I would like to go for the meaning of the kinematic similarity. So what does it mean about? It means that the similarity of the velocity, velocity, then acceleration, okay, of a flowing fluid. किसका आएगा, flowing fluid का जो भी velocity है, जो भी acceleration है, in the model and in the prototype at a particular locations. At a particular locations, जो भी velocity मॉडल में रहेगी उसके सरफेस पे मान लो, सरफेस पे मॉडल में जितनी वेलोसिटी रहेगी उतनी ही प्रोटोटाइप के सरफेस में वेलोसिटी रहनी चाहिए, तब हम उसको क्या बोलेंगे, काइनेमेटिक सिमिलरिटी ऑफ द वेलोसिटी एग्जिस्ट बिटवीन द मॉडल एंड प्रोटोटाइप. Similarly, for the acceleration, if the acceleration of the flowing fluid in a model of a river at a surface and the acceleration of the flowing fluid of a river in its prototype at a surface is the same, then in that case we can say that there exists a acceleration kinematic similarity between the model and prototype of that river. Isn't it? It means that to have a kinematic similarity now, we must need to have a geometric similarity between the model and prototype. It means that if the geometric similarity doesn't exist, then in that case kinematic similarity doesn't exist. It means that the kinematic similarity is dependent on the geometric similarity. If geometric similarity exists, then and only then the kinematic similarity is to exist. It means the velocity acceleration of the flowing fluid at a particular point, that point may be the surface, that may be the midpoint, that may be the at the bottom only, or at the sides, we can say that at those corresponding points, if the velocity acceleration are same in both model and prototype, then we used to say that there exists a kinematic similarity between the model and prototype. Then as the velocity and acceleration both are changing with respect to the time, both are changing with respect to the time, or that is to have a variation with respect to time. So for that, firstly we is to consider the scale ratio for the time. So time scale ratio as a TR, that is equals to time of a model divided by a time of a proto. Why we are considering firstly as a time scale ratio? Because both velocity and acceleration are related to the time. They are varying, they are changing with respect to the time. Okay, then we'll go for the velocity scale ratio now. Now we are knowing velocity scale ratio as a VR is equals to velocity of the flowing fluid at a particular point in the model divided by velocity of a flowing fluid at a particular point in a prototype. Okay, now velocity we are knowing, velocity is a rate of a change of a distance traveled or the length traveled we can covered with respect to the time. It means that a distance will be having distance is having once again as a dimension as a length. So I would like to write a length divided by a time for the velocity in the model divided by length divided by time for the prototype. It means it will be equals to LM, that is the length in the model, divided by time of a model upon length in a prototype upon a time of a prototype. Now if we go for rearranging the same, then we will have the ratio like this: LM by LP. LM by LP, I have taken the length of model divided by length of proto into 1 upon TM by TP, time in a model upon time in a prototype. It means that the velocity scale ratio will be equals to length scale ratio LR divided by a time scale ratio TR. This is about the velocity scale ratio. Then the next ratio which we are going to consider over here, the next one is about the acceleration scale ratio. So acceleration scale ratio is nothing but the AR. It is represented as AR. क्या आएगा इसमें? Acceleration in the model at a particular point of a flowing fluid divided by acceleration of a flowing fluid at a particular point in a prototype. अभी acceleration क्या आता है? Acceleration is the rate of change of velocity with respect to the time, isn't it? Acceleration is a rate of change of velocity with respect to the time आता है. Either we can go in the terms of the velocity, or we can go directly the ratio as a rate of change of length per unit square of the time, isn't it? Acceleration में क्या रहता है? Length divided by time square रहता है. So I would like to go for in that also. It is a length in a model divided by square of the time in the model divided by length of a proto upon in a time square of a proto. Simplifying same, that is a LM by LP into 1 upon TM by a TP. इसका square आ जाएगा. I'm taking square as a common. So that is equals to LM by LP is a length scale ratio upon TM by TP is nothing but the time scale ratio. So it is nothing but the acceleration scale ratio is equals to, we can write the length scale ratio upon the square of the time scale ratio. This is about the acceleration scale ratio. Or the next similarity which used to be there for the kinematic similarity, that is about the discharge. That is about the discharge. So that is a QR. I would like to go for QR is the discharge scale ratio. So that is discharge in a model divided by a discharge in a proton at a particular point or at a particular location. That is QM by QP. Now we are knowing that discharge is having unit as a meter cube per second. Meter cube per second, in it means the length cube in a model divided by per second means the time in a model, divided by, for the proto it will be length cube of a proto divided by a time in a proto, isn't it? So that is equals to LM cube divided by a LP cube into, once again, 1 by time in a model divided by time in a proto. That is equals to cube root of length scale ratio upon the time scale ratio. This is about the discharge scale ratio. It means if these three similarities exist between the model and prototype, then we can say that the model and prototype are kinematically similar to each other. जो भी मॉडल और जो भी प्रोटोटाइप रहेगा उसमें से जो भी डिस्चार्ज हो रहा है, the whatever the fluid is flowing through that, if it's a velocity, it's a acceleration, and the discharge in the model and prototype at a particular location are the same one, then in that case we can say that that model and prototype are having kinematic similarity. And to have the kinematic similarity, the geometric similarity is a must one. Now the third type of the similarity which used to be there, that is about the dynamic similarity. So dynamic similarity means the similarity of the forces. Okay, dynamic similarity is nothing but the similarity of the forces. Dynamic similarity, that is a similarity of a forces. And whatever the forces those are acting on a flowing fluid that we had seen in the previous class, total near about the 6 to 7 forces were enlisted. Is gravity is there, inertia is there, pressure force is there, elastic force is there, then bulk modes of elasticity is there, etc., etc. If those many forces are acting on a flowing fluid, then they results in the rate, in the change of the momentum of that fluid. जो भी उसका momentum है वो momentum change हो जाएगा, यानी कि जब वो सब forces मिलके, नहीं तो एक दो forces मिलके उसके ऊपर act हो जाएंगे flowing fluid के, तब उसका velocity change हो जाएगा. जो भी वॉल्यूम, जो भी मास है, मान लो कि वाटर फ्लो हो रहा है, उसके ऊपर जो फोर्सेस एक्ट हो रहे हैं उनका मैग्नीट्यूड जैसे चेंज होता जाएगा वैसे ही उसकी वेलोसिटी चेंज होती जाएगी. मास कांस्टेंट रहेगा, पानी उतना ही रहेगा, लेकिन उसकी वेलोसिटी चेंज हो जाएगी. इट मींस जो भी उसकी मोमेंटम है, मास इनटू वेलोसिटी, जो प्रोडक्ट आएगा, दैट इज गोइंग टू चेंज. इट मींस टू हैव एन डायनामिक सिमिलरिटी वी कैन से द समेशन momentum of the model and momentum of the prototype of a flowing fluid must be same one, or it has to be a similar one. So I'd like to write in the that language of the momentum itself. Momentum, that is a mass into velocity in a model divided by momentum in a prototype of a flowing fluid at a particular points or at a particular locations must be the same one. Then and only then we can say that there exists a dynamic similarity. ये हो गया पूरा के पूरा, यानी कि summarizing हो गया ये. We have summarized here that is a momentum, means it will be the combination momentum, change of momentum will be the due to the various forces acting on it. It means that if you are going for the various forces, then we can write here the forces as viscous force is there, okay, plus gravity force is there, then elastic force is there, okay, then surface tension force is there, etc., etc. plus किसमें ए है, मॉडल में, कहाँ पे, पर्टिकुलर पॉइंट में जो भी फ्लो हो रहा है उसके साथ जो रेशो आने वाला है किसका, प्रोटोटाइप में जो फोर्सेस एक्ट हो रहे हैं उसका, यानी कि फोर्स ऑफ विस्कोसिटी प्लस फोर्स ऑफ ग्रेविटी प्लस फोर्स ऑफ इलास्टिसिटी प्लस जो भी बाकी सब फोर्सेस हैं वो सब मिला के प्रोटोटाइप में ये जो रेशो रहेगा उनका सभी का, वो यदि मॉडल और प्रोटोटाइप का सेम आएगा तब डायनेमिक सिमिलरिटी एग्जिस्ट होती है। और डायनेमिक सिमिलरिटी एग्जिस्ट होने के लिए ज्योमेट्रिक सिमिलरिटी और काइनेमेटिक सिमिलरिटी दोनों मस्ट है। इट मींस दैट टू हैव a dynamic similarity or to exist a dynamic similarity, the geometric similarity and the kinematic similarities are must. Then and only then the dynamic similarity is to exist. Because momentum change हो रहा है, यानी कि क्या हो रहा है, वेलोसिटी बदल रहा है। वेलोसिटी बदल हो रहा है तो वेलोसिटी सेम होने के लिए मॉडल और प्रोटोटाइप में, यानी कि पर्टिकुलर पॉइंट में मॉडल और प्रोटोटाइप के वो कहाँ पे आती है, वो आती है काइनेमेटिक सिमिलरिटी में। वेलोसिटी स्केल रेशियो एग्जिस्ट होने के लिए क्या चाहिए हमें, लेंथ का जो रेशियो है, स्केल रेशियो वो सेम होना चाहिए। वो कहाँ पे आता है, डायनामिक सॉरी ज्योमेट्रिक सिमिलरिटी में आता है। It means to have a dynamic similarity, the geometric similarity and the kinematic similarities are the must. Then and only then we can say that there exists a dynamic similarity. Otherwise, we can't say there exists a dynamic similarity. But in reality, all three similarities may exist, may not exist. It means that if there exists only geometric similarity, it may happen that there exists only a kinematic similarity. Sorry, geometric and kinematic, and there is not a dynamic similarity. It may happen in a practice, but if you are saying there exists a dynamic similarity, it means that you are saying indirectly there exists a kinematic similarity and the geometric similarity. If you are saying that there exists a kinematic similarity, it means that indirectly you are saying that there exists a geometric similarity. Why is it so? Because for the kinematic similarity, geometric similarity is must, and for dynamic similarity, both kinematic and geometric similarities are the must one. And if all three similarities exist, that is geometric, kinematic and dynamic, between the model and prototype, then it is considered as an similitude. यानी कि similitude यानी कि क्या रहेगा, if there exists geometric similarity, kinematic similarity and dynamic similarity between the model and prototype, then in that case it is considered as an similitude. Means if you are saying a similitude, it means that that particular model and prototype are geometrically similar, then kinematically similar, it is a kinematic similarity, and third one is a dynamic similarity. If all three similarities exist between the model and prototype, then we used to say that that is a similitude. Okay, this is about the basic idea about the similarities and the similitude. Now, to have those similarities, or to govern those things, different model laws are established, or those model laws are also called as a similarity laws. Similarity laws we are going to study here are Reynolds and Proud model. So what are those Reynolds law and model law, sorry, Proud law, those laws now we are going to discuss in details. So model laws or the similarity laws. Okay, first one is the Reynolds law. What is the Reynolds law, or what is the Reynolds number? Reynolds number is nothing but the rho Vd by mu. In short, I would like to go for. So Reynolds law, Reynolds number I would like to go for Re is equals to rho Vd divided by mu. D or the L. Most of the times for the pipe flow, sorry, for the rivers and the streams, we used to consider the dimension as a length. That is a rho phi L by mu. This is our Reynolds number. It means that for the fluid flows, for the flowing fluid where the viscosity is the dominating force, then in that case, to have a similarity or to bring the similarity between the model and prototype, we need to go for the application of the Reynolds law. यानी कि जब हम ऐसे फ्लो कंडीशंस के अक्रॉस आ जाएंगे जहां पे viscous force is a dominating force, then in that case we need to go for the Reynolds law और रेनॉल्ड्स मॉडल लॉ. सो रेनॉल्ड्स मॉडल लॉ के हिसाब से हमें उसका डिजाइन करना पड़ता है. जो भी उसके लेंथ स्केल रेशो आएगा, उसका वेलोसिटी स्केल रेशो आएगा, उसका डिस्चार्ज स्केल रेशो आएगा, वो सब के सब हमें रेनॉल्ड्स नंबर के हिसाब से करना पड़ेगा। तो कैसे आएगा वो? सो फॉर दैट वी हैव टू राइट द रेनॉल्ड्स नंबर in a model must be equals to the Reynolds number in a prototype. Reynolds number in a model must be equals to the Reynolds number in a prototype. So क्या है Reynolds number अभी? Rho VL, density, velocity into the length divided by the viscosity. This is for the model is equals to density, velocity and the length divided by the viscosity in a prototype. This similarity must be exist. Okay, for the if you are going to apply the Reynolds law, यानी कि Reynolds law अप्लाई करते हो क्या होगा, वो जो सिमिलरिटी आएगी वो सब सेम आएगी। अभी यहाँ पे क्या रहेगा, we'll go for the velocity scale ratio, length scale ratio, then viscosity scale ratio and density scale ratio. It means we are going to have a rearrangement of all those parameters here. So how it will be now? Density of a flowing fluid in the model, that is a rho m I have considered. I am taking this density of the prototype here. So density of the flowing fluid in the model divided by a density of the flowing fluid in the prototype equals to or into, I would like to go for, into velocity of a flowing fluid in a model at a particular point divided by, I'm taking this velocity here, velocity of a flowing fluid in a prototype into the length of the model divided by a length of a proto. Now what else remain? There remain a density, viscosity. So it is equals to 1 upon, I'm taking model by prototype, so it will be mu in a model divided by mu in a prototype is equals to a 1. This product has to be a 1. Now we are knowing density of model by density of proto means the density scale ratio, that is a rho r. Vm by Vp means the velocity scale ratio, that is a Vr. Lm by Lp means the length scale ratio as a Lr divided by density, viscosity scale ratio, that is a mu r equals to 1. But what happens regarding the densities of the flowing fluid? For example, if you have prepared the model of a river which is used for the passing of the water, most of the times, all the times we used to you have a rivers for the passing of the fluid as a liquid as a water only, most of the times. So if you are considering the water, then the density of the water in the river and the density of the water in the model of a river will be the same one. So density becomes 1. Okay, directly. So what will remain here in? It is a velocity scale ratio into the length scale ratio divided by the viscosity scale ratio equals to 1. ये कब ऐसा आएगा? जब जो फ्लूइड आप यूज कर रहे हैं मॉडल और प्रोटोटाइप में, यदि वो फ्लूइड मॉडल और प्रोटोटाइप में सेम है तो उसका डेंसिटी सेम रहेगा और उसका रेशियो क्या आएगा हमारा, उसका स्केल रेशियो हमारा 1 आ जाएगा. From here we will be able to get the velocity scale ratio. कैसे निकालेंगे velocity scale ratio? So velocity scale ratio will be Vr is equals to क्या आएगा, mu r divided by the Lr. Vr we want to have, I have taken this mu r here in, it will be multiplied to 1 divided by length scale ratio. This will be for the velocity scale ratio. Then from the same, that is from the Reynolds law, where we will be able to predict the different scale ratio, that is for the time, velocity, already we had acceleration and discharge. So time scale ratio will be once again Tr is equals to Lr divided by Vr. How come? Velocity is equals to length upon time, length per unit time. So Tr will be equals to Lr by Vr. Vr we are knowing mu r by Lr once again. If you rearrange, then also you will get the simplified form, or let it be, no problem. This is for the time scale ratio. Then acceleration scale ratio, Vr मिल गया हमें, Tr मिल गया. Acceleration scale ratio क्या है हमारा? Lr divided by Tr square है. Okay, Lr divided by Tr square है. नहीं तो क्या है? Velocity scale ratio upon time scale ratio है. Velocity per unit time है. Isn't it? One and same you will get. If you put up the Tr here in Lr by Vr, you will get the again the simplified form. That will we are going to check in the next part. Okay. Then for the force scale ratio as per the Reynolds law, force scale ratio as per Reynolds law, force will be equals to mass into acceleration. Okay. Rate of change of momentum with respect to the time due to the application of the force. So m into a, that is a mass scale ratio into acceleration scale ratio. Okay, so mass is nothing but the per unit time as a density into the volume. Okay, so that is a volume per unit time. That is a q as a area into velocity. So that will be once again density rho r into ar into the vr, that is a velocity scale ratio, into the acceleration scale ratio as a ar as it is. This is for a force scale ratio. And for the discharge scale ratio, qr will be area into velocity. It is a area scale ratio into the velocity scale ratio. This will be the combination for the those are the various ratios we can say as per the Reynolds model law. When we have to go for the Reynolds model law, whenever the dominating force or the fluid condition which is given to us is having a dominance of the viscosity force, then in that case, for the preparation of the model of that prototype, we need to go for the Reynolds model law. And by applying that Reynolds model law, we will be able to predict the various dimensions related to that prototype from the for the various dimension of that model for the given prototype. Okay, it means it is applicable mostly for the motion of the airplanes. वहां पे हमें क्या करना चाहिए? In the motion of the airplanes, we need to go for Reynolds model law. Then flow of incompressible fluids, that is a flow through the pipes. Motion of submarines which are fully submerged in water. Then flow around structures, that is the weirs or the piers we can say, and other bodies, those are completely immersed in a moving fluid. In such conditions, we for the such type of the flow phenomena, including the motion of the airplanes, flow of the incompressible fluid in the pipes, then motion of the submarines which are fully submerged under the water, then a flow around structures like piers of the bridge, etc., or the other bodies, those are completely immersed in a moving fluid. In such cases, for the preparation of the model of such structures, we need to go for the application of the Reynolds model law. This is about an Reynolds model law. Means where to apply the Reynolds model law? Whenever we need to prepare the model of a particular structure which is getting submerged under a water, or the water is going to be under a pressure, or the flowing fluid will be under a high velocity, so not the velocity, that is for the pipe flow, that is a incompressible, then in that case we need to go for the Reynolds model laws. Then the next one is the cloud model law. Means for the construction of the structures, construction of the structures, or sorry, construction of the models of various structures where the flow is due to the gravity. In such cases, we need to go for the Cloudian model law or the Cloud model law. So we'll go for that Cloud model law now. Where when will be required to go for a Cloud model law? That also will go for significance at last. But at the beginning, I want to have an understanding about that. Whenever the flowing fluid or the motion of the fluid is due to the gravity, or whenever the gravitational force is a dominating force along with the inertia force, then in that case we need to go for the Cloud law. So as like in a previous case, whenever we are going to design or any model of a prototype based on the Cloud's law, or where the dominating force is the gravity, in that case the first assumption is that the whatever the Cloud number in the model or at a particular point in a model must be equals to the Cloud number at a particular point in a prototype. This is the basic idea. Then we have to go for the in details. It means we have to put up the now equation formulae for the Cloud number. So formulae for the Cloud number, now as it is related to the flow under gravity, it means that it is related to the open channel flows most of the times, or the flow which is having a free surface and it's a top surface, free surface. Okay, so I would like to go for the formula as like that. In general, we are knowing the formula for the Cloud number as a v by root gd. Okay, so here the formula will be velocity upon a square root of g into the, instead of the d I'm considering here as a length. Okay, length of the channel or cross section of the channel of a model must be equals to the ratio of the velocity upon or with respect to the gravity and the length of a prototype. If these things are existing, then in that case we can say that there is a completely sorry, there is a application of the Proud model law, or the particular model is designed based on the Proud law. अब इसमें क्या क्या आएगा, रीअरेंज करने के बाद वेलोसिटी इन द मॉडल एंड वेलोसिटी इन द प्रोटो आएगा. इट मींस दैट वी आर अरेंजिंग इट नाउ. phi I am taking here as a model, velocity of the model. This phi I am taking of a proto here. So it is a velocity in the model divided by velocity in the proto. That is a velocity scale ratio. It means that velocity of a flowing fluid in a model at a particular point is equals to the velocity of a flowing fluid in at a particular point in a prototype. Okay, so that will be equals to now Pm by a Vp into the g as a acceleration due to gravity. Acceleration due to gravity क्या रहेगा, it will be the similar one. g जो रहेगा आपका, जो वो मैग्नीट्यूड जो रहेगा ग्रेविटेशनल फोर्स का 9.81 मीटर पर सेकंड स्क्वायर, acceleration to gravity, it will be the similar one. Okay, so then also I would like to go for into 1 upon the root of gravity in the model into the length of a model divided by, उसको डिवाइड रहेगा करेगा, कौन डिवाइड करेगा, ए वाला, gravity in the prototype into the length in the prototype, that is equals to 1. By rearranging those things we will get Pm by Vp. Okay, इसको Pm by Vp will be a velocity scale ratio as Vr into 1 by है, so I would like to go for a Vr upon Gm by Gp, यानी कि gravitational acceleration due to gravity उसका scale Gr आएगा, और Lm by Lp यानी कि length scale ratio आएगा. It is a velocity scale ratio upon Gr, that is the acceleration due to gravity scale ratio into the length scale ratio आ जाएगा, Lm by Lp वाला. Okay, and G जो रहता है हमारा वो same रहता है. Let it be now. So from this now we'll get the velocity scale ratio directly. Velocity scale ratio Vr will be equals to directly root Gr into the Lr, and if the Gr is equals to 1, then we used to get directly Vr is equals to root of a Lr, or the length scale ratio is equals to square of the velocity scale ratio by the Proudian model law. Okay, or we can take the power also here, as a power will be the 1/2 for the length scale ratio. Here ELT might be you are observing, this is a length scale ratio. Now the various scale ratios related to the time, velocity, acceleration, and the force and discharge from the Proud's model law, we'll derive them now. So first one I have to go for, it is a time scale ratio. So time scale ratio, it is a TR is equals to length of a model, isn't it? Time scale ratio is equals to Lr by Lp. I would have to go for that directly. Lr by Vr from the velocity I am writing here. Lr by Vr कैसे लिख दिया मैंने यहाँ पे, हमें क्या मालूम है, velocity is equals to length upon a time, isn't it? Velocity is rate of change of length with respect to time. So T will equals to L by V. Just now in the form of the Vr I have written over here Lr in the form of the ratios. So that is a TR is equals to length scale ratio divided by velocity scale ratio. Now we are knowing length scale ratio or the Vr velocity scale ratio. I would have to go for velocity scale ratio as root Lr. So it will become now the time scale ratio TR is equals to length scale ratio divided by velocity scale ratio as root of Lr. That is equals to length scale ratio, यानी कि Lr है, so मैं root में ले लेता हूँ, that is a root Lr into the root Lr divided by root Lr. Okay, एक root Lr cancel हो जाएगा, so what will be there? Time scale ratio will be equals to root of Lr only, isn't it? So velocity scale ratio and the time scale ratio for the models, those will be get prepared by the Proud's law. It will be the same one, that is a root Lr. Now similarly after the time scale ratio we'll go for the acceleration scale ratio as AR. AR is a Vr by Tr, velocity scale ratio upon the time scale ratio. Okay, velocity scale ratio we are knowing root of Lr divided by time scale ratio, again we are knowing root of LR. So it will be directly as a 1. It means if the models and prototypes are designed, sorry, model is designed based on the third model law, then the acceleration scale ratio will be the 1 for that case. Next one is the force scale ratio. Force is equals to mass into acceleration. That is a mass scale ratio into acceleration scale ratio, isn't it? So that is equals to, now acceleration scale ratio is 1. So force scale ratio will be equals to directly as a scale ratio of the mass, means mass of the flowing fluid in the model divided by mass of the flowing fluid in the prototype. And the lastly, the discharge scale ratio. Discharge क्या रहता है हमारा? Discharge is nothing but the area into velocity. So QR is equals to AR into VR. AR into the VR. Okay, AR is a square of the length. It is the LR square that we are knowing from the basic only, from the geometric properties only, geometric similarity. So AR is a LR square into the VR. For this case is a root LR, root of a LR. So that will become as a QR is equals to LR raised to 5/2, or QR is equals to LR raised to 2.5. This is about the discharge scale ratio by the Proud model law. Okay, it means if you want to design a model based on the Proud's law, where the dominating force is a gravity, then in that case, you for the adoption of the velocity scale ratio, velocity will be required to go for the scale ratio as a VR is equals to root of LR. For force, will be required to adopt the scale ratio as the FR is equals to MR, and for the discharges will be required to go for the scale ratio as QR is equals to LR raised to 2.5. Now the in general applications I would like to go for. Here it is used for the free surface flows. That is means the flow under gravity. That may be the flow in the open channel. That may be the flow over the spillways. Okay, that may be the flow over the any structure, or flow from a jet from the orifice or the nozzle. Free surface flow. Then flow of the mixed fluids, differently mixed fluids, यानी कि जो भी मिक्स्ड फ्लूइड्स रहेंगे उसका उस पे उसका जो मॉडल हम बनाते हैं उसी वक्त भी हमें Proud's मॉडल लॉज अप्लाई करने पड़ते हैं. This is about the model laws, यानी कि whenever you want to prepare a model, in that case we need to go for a particular type of the law for the finding its various dimensions, various forces, velocities, length, etc., etc. And for that we need to go for either model, those we have discussed as either Proud model law or the Reynolds model law. Reynolds model law will be employed whenever the dominating force is a viscous force along with the inertia force, and a Proud model law will be applied or used or preferred with the when the dominating force is an gravity force along with the inertia force. Okay, so this is about the basics, those we are required for the solving the various numericals and questions those were asked in the GATE examination. Now we'll go for the questions directly, and I would like to take the questions now. So first one, it was asked in a GATE 2015. Okay, so question is now in front of you. What is that? The relation between the length scale ratio LR and the velocity scale ratio VR in hydraulic models in which Proud dynamic similarity is maintained is. It was asked in a GATE 2015. The options are given to us. VR is equals to LR, LR is equals to root VR, VR is equals to LR is to 1.5, and last option is that VR is equals to root of LR. It was asked in GATE 2015. Okay, it was asked in a GATE 2015 for the 2 marks. So how to go for now? Tell me the answer. Which is the correct option here?
D.
Which option is correct here? D.
D.
GATE 2015 1 mark. What is the correct option? क्या है, अभी हमने डिराइव कर दिया था. As per the Proud's model law. I have got the answers, various answers. That is option D, option D, option D. It is absolutely correct one. Option D is a correct one. Just now we had seen that. It was asked in a GATE 2015 for the 1 mark in a set 2. दो set थे, morning or evening वाला. इसमें से I don't know how many sets were there. In the set 2, it was asked for a 1 mark. Okay, I will repeat once again the question. The relationship between the length scale ratio LR and the velocity scale ratio VR in a hydraulic models in which Proud dynamic similarity is maintained is options: VR is equals to LR, LR is equals to root VR, VR is equals to LR is to 1.5, and VR is equals to root LR. So correct option here is a VR is equals to root LR. The next question I would like to go for, it is related to the models. In a laboratory, it was asked in a GATE 2018. Okay, GATE 2018 for 2 marks in a set 1. Okay, GATE 2018 for 2 marks in a set 1. This question was asked. Question is like this: in a laboratory, a flow experiment is performed. कि laboratory में क्या किया है उन्होंने experiment किया है, flow experiment over a hydraulic structure. Hydraulic structure था, उसके ऊपर experimentation किया है. What they did, the measured values of a discharge and a velocity are, इनकी जो भी discharge है और जो भी velocity है, those are 0.05 meter cube per second and 0.25 meter per second. Mean discharge is about 0.05 meter cube per second discharge, और velocity जो है it is a 0.25 meter per second respectively. If the full scale structure 30 times bigger is subjected to a discharge of a 270 meter cube per second, then the time scale model to the full scale, the time scale value is, time scale value क्या रहेगा उसका? This is asked to calculate. Okay, this was asked to calculate. कितने मार्क के लिए था? It was for the 2 marks. Okay, अभी पहले हमें क्या अंडरस्टैंड करना है, क्या क्या दिया है यहाँ पे और क्या क्या पूछा है हमें. So what is they had given? They had given that the experiment was performed. किसके ऊपर परफॉर्म किया है? हाइड्रोलिक स्ट्रक्चर के ऊपर परफॉर्म किया है. अभी हाइड्रोलिक स्ट्रक्चर के ऊपर परफॉर्म किया है, ओव्हर म्हटलंय, बरोबर आहे का? Over a hydraulic structure means the flow will be under a gravity. It will not be under pressure. The flow will be under gravity. Okay, this gives us a clue about which type of the model law is employed or used for the design. जो मॉडल प्रिपेयर किया था वो प्रिपेयर करने के लिए कौन सा मॉडल लॉ यूज किया था उसका आइडिया हमें यहाँ पे आता है. कौन सा मॉडल लॉ यूज किया होगा? रेनॉल्ड्स किया होगा या प्राउड किया होगा? प्राउड मॉडल यूज किया होगा. एग्जैक्टली. सो आई हैव टू गो फॉर द एप्लीकेशन ऑफ द model law as a proud. Yeah, R I am writing here. Okay, proud model law. Firstly, from here we got, because the flow is over a hydraulic structure. Then what they given, the discharge and the velocity, let it be whatever they had given. We will go for writing here. Discharge Q is equals to 0.05 meter cube per second and the velocity as a 0.25 meter per second. This is the idea which they had given to us. Okay, then if the full scale structure, if the full scale structure 30 times bigger, if a full scale structure 30 times bigger, ये 30 times bigger यानी कि क्या दिया है हमें? स्केल रेशो दिया है उन्होंने. जो भी स्केल रहेगा उसका डिजाइन करते वक्त वो स्केल हमें दिया है. So if you go for the length of a model to the length of a proto, that is the length scale ratio I want to go for. Length of a model divided by length of a proto, then this 30 will be length of a model and 30 will be the length of a proto. मॉडल की लेंथ 30 रहेगी या प्रोटो की लेंथ 30 रहेगी? प्रोटोटाइप का लेंथ 30 रहेगा. Exactly, it means the length of model will be 1, then in that case length of the prototype will be the 30. This is the idea they had given to us. Okay, यानी कि ये जो स्टेटमेंट है उसमें से हमें मिल जाता है, यानी कि जो भी हमें दिया हुआ वैल्यूज है 0.05 और 0.25, जो डिस्चार्ज और जो वेलोसिटी है, ओके, वो डिस्चार्ज और वेलोसिटी मॉडल का है या प्रोटोटाइप का है रे? 0.05 और 0.25, this discharge is in a model या is in a prototype?
model,
मॉडल मतलब रहेगा, क्यों रहेगा? वंस अगेन गो फॉर द क्वेश्चन स्टेटमेंट, इन अ लैबोरेटरी, लैबोरेटरी भी किया है तो एग्जैक्टली प्रोटोटाइप नहीं रहेगा, मॉडल रहेगा। इन अ लैबोरेटरी द फ्लो एक्सपेरिमेंट इज परफॉर्म्ड ओवर अ हाइड्रोलिक स्ट्रक्चर, द मेजर्ड वैल्यूज ऑफ डिस्चार्ज एंड वेलोसिटी किसके ऊपर रहेंगे? वो एक्सपेरिमेंट के दौरान ही रहेंगे। सो दिस विल बी रिलेटेड टू द मॉडल क्यू एम एंड वी एम। मॉडल का डिस्चार्ज, मॉडल का वेलोसिटी दिया है, उसके बाद में क्या दिया है? इज सब्जेक्टेड, यानी कि इफ अ फुल स्केल स्ट्रक्चर, फुल स्केल स्ट्रक्चर यानी कि क्या रहेगा? प्रोटोटाइप रहेगा। 30 times bigger is subjected to a discharge of 270 meter cube per second, यानी कि this 270 meter cube per second is a discharge in a prototype. Actual structure we can say 270 meter cube per second. We don't know exactly those given values are required to be or not, but we will go for them firstly as they had given. Just a minute. Okay, so we have taken all the values here. Okay, qm दिया है, qp दिया है, vm दिया है, और उन्होंने पूछा क्या है हमें? क्या पूछा है हमें? टाइम स्केल रेशियो पूछा है। अभी टाइम स्केल रेशियो यानी कि हमें टीआर निकालना है। व्हाट विल बी द टीआर फ्रॉम द गिवन एलआर एज द फ्रॉड मॉडल लॉ विल बी यूज्ड, क्योंकि हमें यहाँ पे जस्टिफिकेशन क्या है? हियर द फ्रॉड मॉडल लॉ विल बी यूज्ड, फ्रॉड मॉडल लॉ इज यूज्ड, विल गो फॉर, क्योंकि फ्लो कैसा है? अंडर ग्रेविटी है। सो एज पर द फ्राउड लॉ वी आर नोइंग द टाइम स्केल रेशियो, वी आर नोइंग अ टाइम स्केल रेशियो। क्या है टाइम स्केल रेशियो एज पर फ्राउड मॉडल लॉ? टीआर इज इक्वल्स टू, जस्ट नाउ वी आर डिराइव्ड दैट,
under root LR.
अंडर
under root
एलआर। if you are not remembering, if you are not remembering, then go for the deriving it, and that will be the better one. कैसे डिराइव करोगे? आपको मालूम है, क्या मालूम है आपको? कि जो भी हमने फ्रॉड मॉडल लॉ की यूज किया है, तो क्या रहेगा? फ्रॉड नंबर इन अ मॉडल विल बी इक्वल्स टू अ फ्रॉड नंबर इन अ प्रोटोटाइप by the same equation. Okay, by the same equation you will get the, once again, the time scale ratio. Okay, then after that we have to go for the derivation of that particular scale ratio. टाइम स्केल हमें चाहिए था, तो क्या रहेगा? रूट ऑफ एलआर रहेगा। सो पुट ऑफ द वैल्यूज हियर, टीआर इज इक्वल्स टू, लेंथ स्केल रेशियो हमें मालूम है 1:30 है, सो इट विल बी 1/30. सो व्हाट इज द आंसर नाउ? How much?
0.182.
0.182.
182.
What is the next digit? We'll go for all the digits first. Yeah,
6.
1826.
6.
ओके, यहाँ पे पूछा हमें क्या है उन्होंने? अप टू 2 डेसिमल पूछा है। if they have asked up to 2 decimals, means in that case we need to go for the writing the answer or putting the answer in the options in the 2 digits only. ओके, वहां पे बहुत बार क्या रहता है? रेंज दिया होता है। अभी यहाँ पे मेरे पास बहुत सारे आंसर्स आए हैं। I got the various answer 0.1826, 0.1826, 0.1826, then 0.2, 0.1826 likewise. Number of the students had given the answer here, but if you go for the 2 decimals, then what will be the answer? Up to 2 decimals, what will be the answer here?
0.18.
0.18 will be there. If you go for rounding this, it will be 3. Okay, 6 का हमने राउंड अप कर दिया तो कितना होगा? वो 3 रहेगा, isn't it? यानी कि 0.183 रहेगा, हमें चाहिए 2 डिजिट्स में, यानी कि 0.8 ही आएगा, 0.18 आ जाएगा। ओके, so 0.2 is correct, but when up to 1 digit, if you go for up to 1 digit, then in that case the answer that is 0.2 is correct, but here they have asked up to 2 decimal places, so we need to go for the answer as a 0.18. Understood? Have you understood this one?
Yes, sir.
Yes, sir.
So the next question we will go for now after this one. This one. It was asked in GATE 2008 for the 2 marks. I would have to go for the here they had given options also. Previously they were giving options, but nowadays for the numerical oriented questions, they directly ask the putting of the answer there. Okay, so the question is like this: a river reach of 2 kilometers long with maximum flood discharge of 10,000 meter cube per second is to be physically modeled in the laboratory. Means these dimensions are related to the prototype actual river. Okay, where maximum available discharge is a 0.2 meter cube per second. It means the discharge in the model will be 0.2 meter cube per second. Then for a geometrically similar model based on the equality of a Proud number, and Proudian law will be applied here. Okay, based on equality of the Proud number, the length of the river reach in a meter in the model is, यानी कि question I would like to go for firstly, जो river है actual उसकी length है 2 kilometers. मान लो कि this is an our river, okay, और उसकी जो length है that length is about 2 kilometers. और उसका जो discharge है that is a 10,000 मीटर क्यूब पर सेकेंड. इसको हमें मॉडल करना है, इसका मॉडल बनाने का है हमें. उसके लिए उन्होंने क्या दिया है, जब आप उसका मॉडल बनाओगे, मान लो कि उसका मॉडल जो है दिस विल बी इट्स मॉडल. आई एम अज्यूमिंग दिस इज अ प्रोटोटाइप एक्चुअल रिवर एंड दिस इज द मॉडल. उन्होंने क्या दिया है, उसमें से जो जाने वाला डिस्चार्ज है Q विल बी 0.2 मीटर क्यूब पर सेकेंड. दिस विल बी फॉर प्रोटो, दिस विल बी फॉर अ मॉडल. इसका जो लेंथ है दैट विल बी लेंथ ऑफ द प्रोटो एंड दे आस्क्ड टू कैलकुलेट दिस लेंथ ऑफ अ प्रोटोटाइप. उसका लेंथ कितना रहेगा इफ इट इज model will be for a carrying capacity of a 0.2 meter cube per second directly by the Proud's law. They are given the options also 26.4, 25.0, 20.5 and 18.0 in the meters. It was asked in a GATE 2008 for 2 marks. Okay, GATE 2002 में 2 marks के लिए एक क्वेश्चन हमें पूछा था. How we will go for? Anyone? How you will go for? Proud model है, isn't it? Answer I am getting here. That is the correct one. That answer is also correct one. How you have calculated now? You just tell me. I will go for solution. I would like to write here firstly. Given data, I would like to go for length of the river, that is a prototype, is a 2 kilometers. Then discharge in the river, that is a prototype, they had given us 10,000 meter cube per second. Then discharge in the model QM, they had given us 0.2 meter cube per second. And what they asked the length of a model. रिवर का जो मॉडल आप बना रहे लैबोरेटरी में उसका लेंथ क्या रहेगा by Proud model law. They are given us, we have to use the Proud model law. So as per the Proud law, we have to find out the length of a model. Now tell me how you will go for, which relation, which formula, which scale ratio. It's a 2-step example. It's only a 2-step example. Anyone?
First, we find discharge scale ratio.
By discharge scale ratio. Okay, so discharge scale ratio I'd like to go for QR is equals to discharge in the model divided by discharge in the proto. Okay, that discharge scale ratio QR is equals to QM by QP hai. Okay, or we know that discharge is the area into the velocity. Area is a length square, velocity is the time scale, and time scale ratio for the for the Proud number is a root LR. I will have to go in the details. Okay, firstly QM by QP, you are knowing that. So how to derive if you are not remembering? QR is equals to area into the velocity, area scale ratio into the velocity scale ratio. एरिया स्केल रेशियो क्या रहता है, स्क्वायर ऑफ द लेंथ स्केल रेशियो इनटू pr is nothing but the velocity scale ratio as per the Proud model law is a root of lr, isn't it? Is it correct? Root of lr, root of lr, is it correct? Yes, something went wrong here.
Root
Yes,
LR
sir.
2.5.
What is that? What is the velocity scale ratio?
QR equal to LR raised to 2.5 na sir.
No, that is a direct one. That is a direct one. But as per the Proud law, what is the velocity scale ratio I'm talking about? As per the Proud law, what is the velocity scale ratio? Is it LR?
Root LR.
Root LR.
Root LR, sir. Root LR.
And if you go for the combination of the powers, that is a LR raised to 2 and LR raised to 1/2, then we used to get the power of the LR as a 5/2, that is LR raised to 2.5. When we have to go for this case, if you are not remembering the equation, not remembering the ratios, then in that case we have to. Basics must be the clear one. Okay, so now put up here. So we are knowing now as QR is equals to LR raised to 2.5 or 5/2, and QR is nothing but the QM by QP is equals to LR raised to 2.5. Okay, so LR raised to 2.5 means what? Length in a model divided by length in a proto. So go for that. QM divided by QP is equals to length of a model raised to 2.5 upon length of a proto raised to 2.5. Now just to put up the values, QM we are knowing, QM is a 0.2 divided by QP कितना है, 10,000 है, 10,000 is equals to length of model we want to calculate, पावर है उसका 2.5 डिवाइडेड बाय लेंथ ऑफ प्रोटो वी आर नोइंग 1 किलोमीटर ना, कितना है उसका, 2 किलोमीटर है,
2 kilometer.
2 किलोमीटर्स. ओके, नाउ यहाँ पे देखो, हाँ डिस्चार्ज है मीटर क्यूब पर सेकेंड में दोनों का, लेकिन लेंथ दिया है हमें किलोमीटर में, तो हमें लेंथ क्या करना चाहिए, पहले
मीटर मध्ये कन्वर्ट करावं लागेल.
we will be required to convert to the meters. So 2 into 1 किलोमीटर यानी कि 1000 meters, इसका पावर रहेगा 2.5. just rearrange the terms, you will get the length of a model, means length of a river in the model. Tell me the answers, that will be in meters. Is it 2.64 or 26.4?
26.4.
26.4. okay, that was the by mistake you had written 2.64. okay, 26.4. okay, so someone has written as option A. okay, right. Okay, I'd like to go for 26.4. 26.4 meters. 26.39 आया था ना, 39 means rounding the figure, we will get 26.4. so correct option will be the option A here. Okay, 26 point, that's the correct one. Understood now about this, how to go for? Understood?
Yes, sir.
Okay, so that now we'll go for the next example. Okay, just a minute. Yeah, this was asked in GATE 2007 for 2 marks. Question I would like to go for firstly, a 1 in 50 scale model, means length scale ratio is given to us, length of 1 meter in the model, 50 in a prototype. Okay, a 1 in 50 scale model of a spillway is to be tested in the laboratory. The discharge in the prototype is a 1000 meter cube per second. The discharge to be maintained in the model test is, this is like in a previous example only, but some changes they had given us, scale ratio they have changed here. Okay, scale ratio. In the previous one, they had given directly discharge scale ratio and they have asked to have a length. Okay, here length scale ratio is given to us and they have asked the discharge. Okay. Now we'll go for the solution part of this. Firstly, I would like to go for the data which is given to us. As now we are knowing, this is as like in a previous example. I'd like to go for scale, length scale ratio. LR is equals to length in a model, length of model divided by length of proto is equals to 1 by 50. It means that if the length of proto is 50 meters, then length of model will be 1 meter. It is the idea. Then our क्या क्या दिया है? A 1 in 50 scale model of a spillway is to be tested in the laboratory. The discharge in the prototype is 1000 meter cube per second. So discharge in a prototype is given as a QP is equals to 1000 meter cube per second. Discharge to be maintained in the model, that is a QM they have asked. In the model, what will the discharge that they have asked, and this same question was asked in 2018 also. In the 2007 they had given options, but I don't know if their options are there. Yeah, options are there. In 2007 they had given us options: 0.57 meter per second, 0.08 meter per second, 0.57 meter per second, and 5.7 meter per second. Okay, let it be, it doesn't matter. We'll go for the solution part and we'll see that which option is a correct option for this particular case. A option is correct. Now we'll go for the solution of that. Now how to go for? Firstly, we must be in the position to decide on which law this model will be prepared. Which law will be used? Is the Reynolds law will be used or the Proud law will be used? Which one? Reynolds or Proud? Proud model. But why Proud model law? Proud law will be the best. But why? Proud law के हिसाब से इसका मॉडल क्यों प्रिपेयर किया जाएगा? Because this is the spillway, means the water is flowing over the spillway that is under gravity. Free surface water is there, free surface flowing water is there. Okay, so Proud model law will be used. Now we have to go for the length scale ratio, utilization of length scale ratio LR and the discharge scale ratio. Means we will be required to go for application of the relation between the length scale ratio and discharge scale ratio. So from the Proud law, we are knowing the discharge scale ratio QR is equals to LR raised to 2.5. Basic equation. Discharge scale ratio Q in the model divided by Q in the prototype is equals to the length in model divided by length in a proto raised to 2.5. ये दोनों की पावर 2.5 है. अभी हमें दिया क्या है? लेंथ स्केल रेशियो दिया है डायरेक्टली 1:50 और डिस्चार्ज इन द मॉडल पूछा है. So we'll go for that. Discharge in the model, which is unknown to us, divided by discharge in the proto, it is a 1000 is equals to length scale ratio 1:50. It is 1/50 raised to 2.5. The thing is that just we have to simplify it. So QM is equals to 1000 into 1/50 raised to 2.5. Now tell me the solution. Final answer.
Option A.
0.0565.
0.056. Next digit. 0.056.
5.
Now by looking towards the options, now we have to select the appropriate option here. So here first option is 0.057, second is 0.08, third one is 0.57, and last one is a 5.7. All answers we are finding close to each other except the B. We are finding the remaining three options close to each other. यानी कि यहाँ पे 1000 का 100 हो गया या 1000 का 10,000 हो गया, then you will get the change in the answers. That is the idea. Okay, so now if you go for the rounding of the same, then we will have QM is equals to 0.057. 6 का क्या हो जाएगा 7 हो जाएगा. So correct option is option A, that is 0.057. It was asked for 2007 and the same question was asked in 2018. Okay, but the marks were only 1 mark for the set one. We'll go for that also. This is about the question which was asked in a GATE 2007. It was related to the Proud law. Why we have used the Proud law? Because it is related to the discharge or the flow conditions over a spillway. And whenever the flow is to there over a spillway, it means there is a free surface flow. It is a flow under a gravity, and to govern that flow, we have a Proud law. So we used the scale ratio as per the Proud law. Now we'll go for the next one. It was asked in GATE 2018, one and the same as the previous one, but the whatever the statement they had given, the statement they have changed. Okay, so I will go for that one firstly. A 1 in 50 scale model. 1 in 50 scale model means the scale ratio regarding the length is given to us. I would like to go for a side by side. Here they had not given the solution because they have asked up to 2 digits. So I will go for firstly question. So 1 in 50 scale model of a spillway is to be tested in the laboratory. The discharge in the prototype is a 1000 meter cube per second. The corresponding discharge in meter cube per second up to 2 decimal places. Up to 2 decimal places means we have to go for 2 decimal points to be maintained in the model. Neglecting variation in the acceleration due to gravity is in the test is यानी कि ग्रेविटी जो एक्सेलरेशन टू ग्रेविटी निगलेक्ट करना यानी क्या GR जो रहता है हमारा इन Proud law, जो ग्रेविटी रहेगा फॉर द मॉडल एंड प्रोटोटाइप for both of them will be the same one, 9.81. That's why it is asked to neglect. Then acceleration scale ratio, I think that is a 1 AR. Is it like that? Yeah, for Reynolds law it is 1. For which case that acceleration scale ratio is 1? Reynolds law or Proud's law?
Proud's law.
It is that if you are going to neglect them, it is not going to have any what we can say, any alteration in our solution. This is the idea. And model is related to the spillway. It means we need to go for the once again the Proudian model law, isn't it? So as like a previous one, only a question is there, but I would have to go for the solution. So given data includes the length scale ratio LR is equals to LM by LP is equals to 1 by 50. In some of the books you will find the ratio as a opposite one, LP by LM, proto 2 model, but you will get the answers as the same one. Discharge ratio bhi uska ulta ho jayega, likewise we will get the answers, but I am following the standard methodology as a model to the proto. Then the next idea which they had given us, there is a discharge in the proto, that is a QP is equals to 1000 meter cube per second. Then corresponding discharge in meter cube per second up to 2 decimal places to be maintained in the model. So QM is asked to calculate, neglecting gravity and all those things that will not be required. So here first and most important thing is that the law which is applied that we must know about. Here the Proud law will be used. Okay, why? Because the flow condition is of a spillway. It is a gravitational force will be dominating along with the inertia. So as per that, we are knowing the relation between the discharge scale ratio and the length scale ratio. That is a QR is equals to LR raised to 2.5. So QR is a QM by QP is equals to length scale ratio LM by LP raised to 2.5. Just now we have to put up the values here. QM we want to calculate. QP I will have to get directly to the right hand side, 1000 into scale as a 1 by 50 raised to 2.5. So once again you will get the answer. QM is equals to 0.0565, yeah, 6 something like that. Up to 2 decimals we have to go for, isn't it? We have to go for 2 decimals. Means what will be the answer now in meter cube per second in 2 decimals? What will be the answer?
0.06.
0.06.
0.06 meter cube per second. This will be up to 2 decimals. In previous case, options were given, and those options 0.057 was option. But here they asked up to the 2 decimals. So in that case, we need to put up the data. हमें वहां पे डायरेक्टली आंसर हमारा टाइप करना पड़ता है. तो हमें क्या करना चाहिए टाइप वहां पे 0.06 मीटर क्यूब पर सेकेंड. It will be the correct answer for the this given question. Okay, now we'll go for the next question. Now it was asked in GATE 2001 for 2 marks. So many examples you will find as like this one. 2001 में क्या पूछा था उन्होंने? A 1 in 50 scale model of a spillway. Once again, the model is related to the spillway only. So scale ratio for the length is given to us 1:50. The discharge was measured to be 0.03 meter cube per second, 0.3 meter cube per second. The corresponding prototype discharge in a meter cube per second is. Options I would like to go for. They had given the options also. Okay. 5303 is this is correct one. 5303 means option D is correct. Okay, that is the option D is correct. Now we have to go for the solution. Option D, that is correct one. We have to go for the solution now. Firstly, understand the question. What they had given? Firstly, they had given a scale. कितना दिया है? 1:50. So I would like to go for in a solution. Given scale ratio LR is equals to length of a model divided by length of a proto is equals to 1/50. Is equals to 1/50. Option D, that is a correct one. But do solve the question. Do solve the question. Length of model to the length of proto, scale as a 1:50 they had given. Then it is related to the spillway. So once again we'll be required to go for a Proud model law. Okay. Then a discharge which is measured on that model is a 0.3. Means QM is given to us is a 0.3 meter cube per second. And what they asked, corresponding prototype discharge, QP is asked. But idea is that firstly we must know which type of the law is used. So here the governing law which is used for the designing of the model of the spillway is a Proud's law. So I'm writing here by making a star here as a Proud law. It will be employed herein. Okay, so Proud law is used. So as per the Proud law now, we have to find out the QP. Means we have to go for the discharge scale ratio, because discharge scale ratio links the length scale ratio with the discharge. So that is a discharge scale ratio. QR is equals to LR raised to 2.5. Then put up the values. QR is nothing but the discharge in a model divided by discharge in a proto is equals to length of a model divided by length of a proto raised to 2.5. Discharge of model दिया है, proto का पूछा है हमें. So discharge of model is a 0.3 divided by discharge in a proto is equals to LM by LP is a 1:50 है. So 1/50 raised to 2.5. Just simplify it. You will get the answer for the discharge in the proto. So what is the answer for the prototype? Answer tell me. Don't tell me option.
5303.3. 3.
Okay, meter cube per second. This is the correct answer which you are getting by calculation. Now we have to check this answer with respect to the available options. So available from the available options, A is not, B is also not suiting, C is also not, D if you are looking for 5303.0 is there. 3 that not given. If you go for rounding up, then 3 will not make any sense. It is not going to get make 0 as a 1. So option A, or by rounding it, you will get the option D as a correct option. It is a 5303.0 meter cube per seconds. Okay. Now we'll go for the next one. This was for the GATE 2001 and it was for the 2 marks. It was for the 2 marks. Simple steps are there. Just thing is that we have to remember the relationship and the law or the model law which is used for the similarity model law we have to remember. Next one, go through this one. I think so this is not that much difficult. It is also an same one as like a previous, but only thing is that we have to adopt the different scale ratio and we have to get the answer. I'll go for firstly the statement. It was asked in GATE 1991 and it was for the 2 marks. Statement is like this: a 1:50 model, a 1:50 model. Answer I got. Okay, I will go for the answer afterwards. A 1:50 model of Ugi spillway means once again a Froude law will be applied here. Ugi spillway crest records an acceleration of 1.5 मीटर पर सेकेंड स्क्वायर, यानी कि जो फ्लो हो रहा है कहां से हो रहा है, उगी स्पिलवे के ऊपर हो रहा है, वहां उसका जो क्रेस्ट है उसके क्रेस्ट के वहां पे जो एक्सेलरेशन है फ्लोइंग फ्लूइड का वो 1.5 मीटर पर सेकेंड स्क्वायर है at a certain location, यानी कि जो भी स्पिलवे रहेगा. I would like to go for the sketch also of Ugi spillway. So Ugi spillway, just a minute, it is to be like this. This is an arbitrary structure I am talking drawing here for Ugi spillway, over which the water is flowing like this. Suppose that this is an sheet of the water flowing over it. You can hear dimension is going, the hydraulic jump and all those things will be get occur at the downstream end. This is the water surface, free water surface I would like to go for. इसके ऊपर इसका जो क्रेस्ट है वो यहाँ पे है. यहाँ पे कहीं पे तो उन्होंने क्या है उसका वेलोसिटी एक्सेलरेशन मेजर कर दिया. मान लो कि दिस पॉइंट दे मेजर द एक्सेलरेशन, और वो एक्सेलरेशन कितना है 1.5 मीटर पर सेकेंड स्क्वायर है. कहाँ पे है, मॉडल में है, उसका मॉडल प्रिपेयर किया वहां पे. द होमोलॉगस वैल्यू ऑफ एक्सेलरेशन इन अ प्रोटोटाइप इज, वैल्यू किसका पूछा है हमें यहाँ पे, प्रोटोटाइप में उसका जो वैल्यू रहेगा एक्सेलरेशन का वो कितना रहेगा. I would like to go for firstly the data which is given to us. They had given firstly the scale ratio. It is a length scale ratio LM by LP is equals to 1 by 50. Okay, then acceleration for the model they had given as a 1.5 meter per second square, and what they asked, the acceleration in the prototype at the same point. यानी कि ये आपका मॉडल है, मान लो आपका प्रोटोटाइप जब थोड़ा सा बड़ा है, मान लो कि this is our prototype, it will be in a larger dimension than that of the model. Suppose that this is our prototype. मान लो कि यहाँ से उन्होंने मॉडल पे 1 मीटर पे मेजर किया है तो यहाँ पे 50 मीटर पे आ जाएगा. दिस पॉइंट पे जो एक्सेलरेशन रहेगा प्रोटोटाइप का, that acceleration is asked to calculate. Anyone tell me why someone has given the answer as a 1.5? Who is that? Sanket. So tell me that why 1.5 and how 1.5?
एक्सेलरेशनचा रेशो सर 1 असते ना, मॉडेलचं एक्सेलरेशन आणि प्रोटोटाइपचं एक्सेलरेशन.
Right.
सो
Exactly.
1.5 आपण 1.5 आल्याशिवाय 1 येणार नाही.
Exactly. Directly you will get the answer here. So what is that? By Froude law. Here the law which will be used, that will be the Froude law. Okay, that will be the Froude law. And as per the Froude law, acceleration scale ratio is a 1. Acceleration scale ratio is a 1. So acceleration scale ratio क्या करेगा? Acceleration in a model at a particular point divided by acceleration in a prototype at a particular point is equals to 1. मॉडल का दिया है हमें 1.5 है, put up the values. 1.5 divided by acceleration in the proto is equals to 1. That is, let's simplify it. 1.5 is equals to, I'm taking this acceleration in proto here, 1 into acceleration in the proto. That is, acceleration in the proto will be equals to 1.5 meter per second square. And that scale ratio regarding the acceleration we have derived. If you are not remembered, If you have not remembered that how it comes to be, then we have to go for the from the basic. How come? Proud model law, Proud's law in the model is equals to Proud's law in the Proud's number in the model is equals to Proud's number in the prototype. That is a phi divided by root GL of a model is equals to phi divided by root GL of a proto. Take the same things here in phi m by a phi p, okay, into 1 upon root of gm by gp into lm by lp is equals to 1. phi m by vp is a velocity scale ratio vr divided by g to same rahega, acceleration due to gravity, means what else remain, root of a lr. Then we are knowing phi r is equals to root lr रहता है, okay. phi r is equals to root lr. Here you will get a vr is equals to root lr. एक इक्वेशन आ गया. बाद में हमें चाहिए क्या, एक्सेलरेशन चाहिए. एक्सेलरेशन यानी क्या रहता है, वेलोसिटी पर यूनिट टाइम, यानी कि वेलोसिटी रेशियो अपॉन टाइम स्केल रेशियो, ओके. वेलोसिटी रेशियो अपॉन टाइम स्केल रेशियो आता है. सो वेलोसिटी और टाइम स्केल रेशियो हमें मालूम है, phi r is equals to root lr है. टाइम स्केल रेशियो क्या रहता है, phi is equals to l by t रहता है. तो टाइम चाहिए हमें, सो टाइम क्या रहेगा, l by v means length scale ratio divided by velocity scale ratio, isn't it? अरे सही है क्या, देखो जो मैंने लिखा है यहाँ पे, टाइम स्केल रेशियो विल बी lr by vr, okay. Then vr is a root lr, so tr is equals to lr divided by root lr, means it will be equals to root of lr. कौन आ गया, टाइम स्केल रेशियो आ गया. डिवाइड कर दो यहाँ पे, एक्सेलरेशन स्केल रेशियो, वेलोसिटी स्केल रेशियो क्या है, रूट एलआर है. टाइम स्केल रेशियो क्या है, रूट एलआर है. रूट एलआर गेट्स कैंसल्स, so acceleration scale ratio is equals to 1. That I have quoted here. How simple it is. Only thing is that we have to remember the key points. Got it down? Understood? GPS, then I will go for the next
Yes,
one.
sir.
Okay, I'll go for the next one now. Just it was asked in GATE 1995 for 2 marks. Question क्या है? Once again, as like a same one, only scale ratio and the discharge is changed, acceleration is changed. What they had given now, a 1:30 model of a Ogi spillway crest records an acceleration of 1.3 meter per second square at a certain location. The homologous value of the acceleration in the prototype is, कितनी रहेगी रे, उसके ऑप्शंस दे दिए हमें उन्होंने. I will go for options also. A has a 0.043, B has a 0.237, C has a 1.3 and D has a 7.12. Now bolo, what will the answer?
ऑप्शन सी.
1.3.
Option C. क्यों आएगा रे ऑप्शन सी? Now I want to have a justification from your side. क्यों रहेगा? See, so many answers I got in the chat box. Why answer C? Anyone? Why answer C is correct? Bolo.
A is equal to AM by AP. AM चं व्हॅल्यू दिले 1.3.
Right. As per the, it will be designed as per the Proud's law. As per the Proud's law, acceleration scale ratio is AM by AP, which is equals to 1. Then model का acceleration दे दिया हमें 1.3 है, so just to put a bit, so 1.3 divided by AP is equals to 1. It is a 1.3 is equals to AP. Only they had given us a 2 digits extra, so correct answer will be 1.3. So 2 times such type of the question was asked in a GATE examination. It was for 1995 and the previous one was for the 1991. But this time in 1995 they asked for the 1 mark. By mistake I had written here as for 2 marks. It was for 1 mark. Okay, so likewise questions used to be there in a GATE examination based on the our Proud's and Reynolds law. Again number of questions are there. I would like to go for the next one. Let's go through it. It was in a GATE 2003 for 1 marks. A laboratory model of a river is built to a geometrical scale of 1:100. The fluid used in the model is oil of mass density 900 kg per meter cube. The highest flood in the river is a 10,000 meter cube per second. The corresponding discharge in the model shall be. Firstly, understand the phenomenon here. क्या दिया उन्होंने? A laboratory model of a river is a built, यानी कि उसका scale ratio जो दिया है हमें, that length scale ratio is given to us. This is LR, LM by LP is equals to 1/100. Length model का 1 मीटर रहेगा तो प्रोटो का 100 रहेगा. The fluid used in the model is oil of mass density 900 kg per meter cube. यानी कि जो भी डेंसिटी दी है हमें वहां पे, डेंसिटी ऑफ लिक्विड इन अ मॉडल इज 900 kg per meter cube. Okay, it is a 900 kg per meter cube. इसके ऑप्शंस भी दे दिए हमें. By mistake I had written here, let it be now. Then the highest flood in the river, it means this discharge is related to the prototype. QP is a 10,000 meter cube per second, and what they asked, corresponding discharge in the model, QM is equals to question mark. Options are also given to us: 0.095, 0.1, 0.105 and 10.5. I got the answers in the chat box. I would like to go for them. 0.1, okay, 0.1, option B someone has written, okay, has 0.1, 0.1, 0.1. Again I got 0.1. So now tell me how you got the answer 0.1. Answer.
तिथे डेन्सिटीचा काही संबंधच नाहीये, फक्त
डेन्सिटीचा संबंध काहीही नसणार आहे. That's the idea. That is the basic fundamental we can say here. There is no relation of a density. Okay, so directly you have to go for the relation as a QR is equals to LR raised to 2.5. I would like to go for solution and then we'll stop here. It will be designed by the Proud's law. So as per Proud's law, the discharge scale ratio related to the length scale ratio, here will be required to go for the length scale ratio. So QR is equals to LR raised to 2.5. That is a QM by a QP is equals to length scale ratio is given to us as a 1:100 raised to 2.5. Put up the value of the given discharge. Proto का discharge दे दिया हमें. So discharge in the model will be equals to proto का discharge है 10,000 into 1/100 raised to 2.5. So tell me the magnitude, not the option. How much? 0.1. 0.1 meter cube per second. And as per that, the correct option for the same is the option B. It was for 1 mark. Now I'd like to go for the another question for homework. Just to go through it for the homework for you. The height of a hydraulic jump in the stilling basin, we can say, of a 1:25 scale model. Scale ratio दिया हमें length 1:25 was observed to be 10 centimeter. 10 centimeter जो height है jump का, that is up in the model. Then the corresponding prototype height of the jump is, was asked in GATE 2004 for 2 marks. Options are also there. Options are, first one is not determinable from the given data, second is 2.5, third is 0.5 and last is a 0.1 meter. Okay, you have to solve it as a homework. Okay. So what we'll do now, today we will stop here, and remaining part, the examples and all those things will go for a next lecture. Okay, so